Welcome, ladies and gentlemen, to some free response question review. In today's episode, we will be discussing the 2006 B version from the Calculus BC, question number 5, non-calculator. It reads, let f be a function with f of 4 equaling 1, such that all points on x, y on the graph of f satisfy the differential equation that thing, and let g equal all that stuff as well. Part A reads, find y equals f of x. So they are going to cut right to the chase. They're not going to mess around. And so before we find y equals f of x, we need to separate the terms. But before I separate the terms, I'm going to do something kind of odd. I'm going to distribute not the 2y, but I'm going to distribute just the 2 only. That might make things a little bit cleaner for us to separate out. So that gives us dy over dx equaling y, and then 6 minus 2x. And now that lets us go ahead and move the y over. So 1 over y dy is equal to 6 minus 2x dx. I'm going to integrate both sides. I end up getting ln of absolute value of y equaling 6x minus x squared plus c. Let's do some exponential work on this thing. So absolute value of y equaling e to the 6x minus x squared plus c. I can say that absolute value of y is equal to e to the 6x minus x squared times e to the c. And then e to the c is really just c. So the absolute value of y equals c e to the 6x minus x squared. The absolute value of y being plus or minus c is really just y being c. So equals e to the 6x minus x squared. Once all of this absolute value stuff is knocked out, that's when I feel most comfortable solving for c. And so we have to remember that the initial condition is that f of 4 is equal to 1. So let's just keep on moving down. That means that 1 is equal to e to the 6 times 1, not 6 times 4. 6 times 4 minus 4 squared. That's going to be 24 minus 16, so that's going to be 1 equals e ce to the 8th. And then that just means that c equals 1 over e to the 8th. So where is this going to help me? It's going to help me right here, and it looks like I forgot c. My apologies. C is going to go there. So I get y equals, instead of calling him 1 over e to the 8th, I'll call him e to the negative 8th times e to the 6x minus x squared. And then if I really wanted to combine them out, they probably wouldn't care either way. I would say negative 8 plus 6x minus x squared. Okay, that should wrap it up for A. Let's go move on to part B. All right, part B, it says, given that g of 4 equals 1, find the limit as x goes to infinity of g of x, and then the limit as x goes to infinity of g prime of x. And it says it's not necessary to solve for g or to show how you arrived at your answer, so basically we have to show no work. What you want to recognize in your g of x function, which is this guy, is that he's almost logistic. What you want to do is you want to see him a little bit differently, though. You want to see dy dx here equal to, and I'll actually switch to a different color, something darker so it stands out. You want to see him as 6y and then 1 minus y over 3. And why does this help you? It's because when you see it like this, now you can see a couple things. You can see carrying capacity, you can see carrying capacity, and all that good stuff. So from here, the limit as x goes to infinity of g of x is going to be the carrying capacity, which is 3. And then, as long as you know what the logistic growth graph looks like, as the logistic graph adjusts and grows towards its carrying capacity, its slope, its g prime, will approach 0. So that's really all you had to do for B. Moving on to part C, another straightforward one as long as you understand logistic growth. It says, for what value of y does the graph of g have a point of inflection? Find the slope of the graph at g at this point of inflection, and it's not necessary to solve for g of x. Okay, well, as long as you understand this whole carrying capacity idea, then you could say that the point of inflection, actually I'll type this out. You could say G has a point of inflection at x equals 3/2 because 3/2 is 1/2 the carrying capacity of 3. Now actually, I don't think it actually even asked you to justify why that was a point of inflection, but you know, it's always good to know why that is. And now we have to find out what the slope is at that moment in time. So that's going to be dy over dx at y equals 3/2. Well, what is that? That's going to be 2 times 3/2 times 3 minus 3/2. So that's going to become 3, and that's going to become 6 over 2 minus 3 over 2. So we've got 3 times 3 over 2, which becomes 9/2. And I think that's going to wrap it up for A, B, and C of this Calculus BC Diffie-Q. So as always, if you have any questions, leave them in the comments, and I will see you in the next episode.